In this lecture we will discuss about molarity, which is probably the most common unit used in chemistry, and it's used to express composition of mixtures, but a particular kind of mixture that for our purposes we call solutions. And solutions, just so you remember, solutions are mixtures. And remember, two or more pure components, could be elements, could be compounds, but mixtures nonetheless. But when you refer specifically to solutions, you are referred to mixtures that are homogeneous. Okay? And usually that solution will be made out of a solute and a solvent. And when it comes to solutes, probably it's just not one, but it could be many solutes. So with that in mind, one of the things that we need to know is to learn about all these concepts here: solvent, solute, concentration, what is concentrated solution, what is a dilute solution. Of course, define molarity, how you can calculate molarity, and more importantly, how can you use molarity to calculate the concentration of a given solute in a solution, or to calculate any other quantity related to molarity, being moles of solute, being volume of solution, or you can even calculate mass of solute. So, what is molarity? Molarity is simply the number of moles of that solute per volume of solution. And well, here you have the moles of solute, and when it comes to volume of solution, it's a very specific unit of volume. You are using liters of solution. And just so you remember, you are expressing the amount of solute in that solution, and the solution, remember, is made out of the solvent and the solute. So one other important relationship that you need here is that when you look at the mass of the solution would be equal to the mass of the solute plus the mass of the solvent. And this is a relationship that will always be true. Okay, because you can see it from the point of view of law of mass conservation. Everything that you have at the beginning of any process, in this case the process is the dissolution of a solute in the solution, whatever you have at the beginning of that process has to be equal to the mass that you have at the end of that process. Okay, and this is just a reminder: if you have moles of solute, or you want to calculate moles of solute, you need the mass of the solute and of course the molar mass of the solute. That is a basic relationship that you should know by now. But again, molarity, when you calculate molarity, the concentration of a given solution, it's the number of moles of the solute divided by the volume of the solution. Remember, that volume has to be liters. Okay, another relationship that you may use sometimes is that the volume of the solution equals the volume of the solute plus the volume of the solvent. However, this is not always true. And it's not always true because sometimes those volumes just don't add to each other. Okay, you will be given that information whether you can consider that you can add the volumes or not. But if nothing is said, do not assume that they are you can add the volumes. Okay, so remember, these solutions are homogeneous mixtures, and you have a solvent and a solute, and the way to differentiate the solvent from the solute is that normally the solute is the component of that mixture that is in the smallest proportion. Not always the case, but normally it's going to be the one in the smallest proportion. And of course the solvent would be in the one in the higher proportion. For most of the things that we're gonna work here, the solvent usually is water. Okay, but you can prepare and make solutions out of anything that comes to mind. So the process usually involves weighing that solute, and then, well, you need to weigh it because you need the mass so that you can calculate the number of moles. If it's a liquid that you are dissolving, well, you can measure the volume, and with density you can calculate the mass, but you need the mass nonetheless because you need to calculate the number of moles of that particular substance. And then you just add the solvent, in this case water, and you add water to complete any given volume that you are preparing. Okay, in this case you are preparing, basically it's 1 liter, so you add 1 mole of sodium chloride, which is 58.44 grams, and then complete with water up to 1 liter. It's not the same that you complete with water to 1 liter as to add 1 liter of water. Sometimes if you just add 1 liter of water, you may end up with a little higher volume, just because you have to account for whatever volume or the effect of that sodium chloride will have in the final volume. So you complete to a volume, you don't add the volume. Okay, so as I said, you can prepare solutions out of anything that comes to mind. Remember, if a solution is a homogeneous mixture, you only see one phase. So you can have solutions in gas phase, solutions in liquid phase, and solutions in solid phase. As long as you cannot distinguish but only one thing and it's uniform throughout, then that's a solution, regardless of the state of matter, solid, liquid, or gas. Examples, for example, in the gas solutions, air would be the best example that we have. In liquid solutions, well, anything comes to mind. You can dissolve a gas, a liquid, or a solid in another liquid, and if you see only one phase, then that's a solution. And solids, well, it could be liquids in solid, or it could be solids in solid. So alloys, metal alloys are examples of solid solutions. Okay. However, we are not going to work too much with solid solutions. We can, but normally the most common that we work in chemistry are liquid solutions. So how do we use molarity? Well, molarity, remember, molarity is relating the number of moles that you have here with the volume, number of moles of that solute, with the volume of solution. Okay, and the connection between those two is molarity. Okay, so let's say you want to go, if you know the volume of solution and you want to calculate the number of moles, then basically what you do is, if you are going that way, so if you have the volume of solution and you want to know the number of moles, well, you multiply by molarity, because molarity tells you the number of moles per volume of solution. If you want to go in the other way, if you want to go from number of moles to volume of solution, then you have to divide by the molarity. So that's the basic relationship between molarity. Volume times molarity gives you the number of moles. Moles divided by molarity give you the volume of solution that contains that number of moles. Okay, we can extend that relationship because sometimes we have the number of moles, but sometimes you don't have anything to measure number of moles directly, so you have to calculate the number of moles, and the way to do that is with a mass, and the connection between mass and number of moles is here. This is the molar mass. So remember, if you have mass and then you want to calculate number of moles, so you first divide by the molar mass, and if you want to calculate the volume of solution, then you divide by molarity. So that's the basic relationship in which that you can go from mass to volume, and you can even go from volume, you first multiply by molarity and then you multiply by molar mass, and that will give you the mass of the solute that you need to prepare that particular volume. Another relationship that we can add here, what if instead of volume of solution you have the mass of solution? Well, the connection between volume and mass, that's density. If you have mass and then you want to know the volume, you need to divide by the density. And if you have the volume and you want to know the mass, then you go multiplying by density. Okay, the same relationship here with mass of solution, you can do it with mass of the solute if you have volume of solute, but we'll keep that out of the way for now. So how do we implement these in solving problems? So how about we calculate the molarity of fructose in a 12-ounce soda can, and that soda can has 40 grams of fructose. Okay, there is no, I don't see, well, we have volume here, and this is mass. I don't see that we need density here, so we can limit our analysis to this. So you have the volume, and then you have the mass, and the question asks you for what is the molarity, so we need to calculate what the molarity is. So you need to go in this direction, and then you need to go in this direction. so that you can calculate the molarity. So if you have mass and you're going in that direction, then you have to divide by molar mass to calculate number of moles, and then with volume of solution calculate molarity, because after all, molarity is moles divided by liters. Okay, remember, this is volume in liters. So we have the mass, we need the molar mass, and then we have that this is fructose, and fructose is 6 times 12,011 plus 12 times 1008 plus 6 times 15,999, and that is 180.156 grams per mole. So number of moles would be equal to those 40 grams that you have there times 1 mole with a mass of 180.156, and that would be equal to 0.222 moles. Now the volume, you have 12 ounces here, but you need that volume in liters. So first step, we multiply by 2957 milliliters, because that's how many milliliters an ounce is, and then we take these 2 liters, and 1 milliliter equals 10 to the negative 3 liters. We end up with 0.355 liters. We combine these two, and the molarity is 0.222 moles divided by 0.355 liters, and we end up with 0.625 molar. This unit right there means moles per liter. Okay, so in the next example, we have how many moles of hydrochloric acid we have in 500 milliliters of 0.30 molar. And remember, we need volume in liters, so we can simply say that those 500 milliliters are 0.500 liters. And then in this case, we don't have mass, and basically we don't need mass, because the question is how many moles. So the question is how many moles we have here. We have the volume, we have the molarity, we are going in this direction, so we have to multiply by molarity. So simply we have the volume 0.500 liters times 0.30. This number here is 0.30. Molar means 0.30 moles per liter, so that's what I'm writing here, and that would be equal to 0.15 moles of HCl. Okay, so in this case, now we have concentration of vinegar. Now we have 0.839 molar, again moles per liter. What volume of vinegar contains 40 grams of acetic acid? So let's keep our diagram there. And acetic acid, this is CH3COOH. Not that you really need to know it, but if anything that we're gonna give you, we will either give you the molar mass, or you will have a formula with which calculate the molar mass. So in this case, we have 2 times 12,100,011, because you have 2 carbons there. You have 4 hydrogens, 4 times 1008, and you have 2 oxygens times 15,999. That adds up to 60.052 grams per mole. So you have the mass. Now we have the molar mass, which means we can calculate number of moles, and then you have the molarity. Okay, we are asking now what the volume is, so we are going in this direction, so you have to step 1 divide by molar mass, step 2 divide by molarity. Okay, so we start here, 40.0 grams of the acetic acid times 1 mole divided by 60.152 grams. This takes care of the grams. At that point you have number of moles. Now with molarity you have to divide by molarity, so it's 1 liter divided by 0.839 moles, and this cancels with that. And at the end of this you have units of volume, and that volume is 0.794 liters, which is the same as 794 milliliters. There is no specification about what units to report the volume, so 0.794 liters is fine. 794 milliliters is fine. In the exam we will tell you what units you have to report this with. This case now, how many grams of lithium chloride we need to add in order to prepare 450 milliliters of that 1.4 molar solution. This volume here is 0.450 liters. So we have volume, we have here the molarity, which you can calculate number of moles with that, and then in this case we are asking for mass. We actually have the molar mass because we had the formula. It's lithium chloride, and for lithium chloride that's gonna be 6941 plus 3545, which adds up to 42,391 grams per mole. Okay, we have everything. Now we are going in that direction. So first you take the volume, multiply, here is your step 1, multiply by molarity, and then this is your step 2, multiply by molar mass. So we start 0.450 liters times 1.4 moles of lithium chloride divided by 1 liter, liters cancel with liters, and then times 42,391 grams, that is 1 mole of lithium chloride. And here we end up with 26.7 grams of lithium chloride. That, well, based on your data, this most likely has to be reported as 27, because 2 significant figures is the largest number of significant figures, the smallest number of significant figures that you have there. Okay, 27 grams of lithium chloride. So this is how you use molarity in calculations. The next step is to use dilutions, but that's going to be a different play puzzle.